Find the regression equation, letting the first variable be the predictor variable, or the x, and the other one be the y. So the data we have on the left is 2 pieces of information from each country. In column A, we have how many people use the internet in that country for every 100 people. And in column B, how many people have won the Nobel Prize for every 10 million people living in the country. So if you look at the first country, it's saying, well, there's 79.7 people out of every 100, or 79.7% of the country uses the internet, and there were 5.4 Nobel Prize winners for every 10 million people living in the country. All right, so we have this information from 23 countries, and we want to use that information to come up with the regression equation, sometimes called the predictor equation. And we'll use that to predict how many Nobel Prize winners would there be in a country that has 78.6 internet users per every 100 people. And then we'll take our prediction and compare it to the rate. So for this country, we're given that 78.6 out of 100 use the internet, and 2 out of 10 million win the Nobel Prize. Okay, so there's a couple of ways that we could do this. I'm going to show you both methods, and neither one are going to be using those really elaborate formulas that are found in the textbook. So I'm not going to be doing any calculations on my own. I'm just going to be using the built-in functions on Excel. Now, both methods always work. It's just a matter of personal preference. So one method for finding the regression equation is to graph it. Graph the data on a scatter plot. So we could highlight the data that we want to graph, go to the Insert tab, and click on the scatter plot icon. And easy as that, we have the data graphed. Now, if we want the equation on this graph, we could select the data. So click on any one of the points. Doesn't matter which point, just pick a point, click on it. So now you see the data selected. And then right click, and you'll see Add Trend Line. So this is what Excel calls that regression line, or that least squares regression line. Excel calls it a trend line. So if we click on trend line, you'll see that the graph of that equation pops up on our scatter plot. So there's the line. So remember, the equation takes the form y equals mx plus b. And if we want the equation, all we have to do is click this box next to Display Equation on Chart at the bottom on the right-hand side. So we click on that, and there's our equation. It's a little small, so let's move it over here, and we could actually make it a little bit bigger so it's easier to read. Okay, and there is the equation that we're looking for. That's the regression equation. So remember, let's say in an algebra class, the equation of the line is given as y equals mx plus b. And it would mean the same thing if we said y equals b plus mx. 2x plus 3 and 3 plus 2x, they mean the same thing. But in the context of statistics, in a stats course, rather than m for slope and b for y-intercept, it's normally written as maybe y hat equals b0 plus b1x. But it's the same, the slope is the coefficient in front of the x, and the y-intercept is the other constant. All right, so we have our regression equation. The directions say round the constant to 1 decimal place. So we'll say that's a minus 22.6. And the coefficient to 3 decimal places. So we'll round this to, let's say, 0.446x. All right, so that is the regression equation. So I'll put those numbers in down here under slope. So the slope is the 0.446. 0.446, and the y-intercept, that is the negative 22.6. Just following the rounding that the directions give us. And I have the correlation coefficient here. It's not necessary for the problem, but just since we have all this data up, might as well calculate the correlation coefficient. So that's equal CORREL parentheses. And then Excel is asking us for the array number 1, which is the x values, and then comma, array number 2, which is the y values. So we have a correlation coefficient of about 0.7, 0.695. That's telling us there's a moderate correlation. Not a very strong correlation. It's not in the 0.9 range, but moderate correlation. And so what we're doing is we're taking this country with 78.6 internet users. So I'll put these numbers down here in the blue cell. So it's like adding a 24th country to the list. 78.6, and in that country there are 2 Nobel Prize winners for every 10 million people. Now, to predict, so we want to find the best predicted Nobel laureate rate. And that's the y value. So find the best predicted y value for a country with 78.6% or 78.6 internet users for every 100. What that basically means is we take this x value and we plug it in for x. And I'll do the calculation down here in this box. But before I do that, let's look at the other method. I don't think it's any easier or any harder. It's just another way of getting those numbers, and that's to use the data analysis Toolpak. And you could find that in the data tab up here. So if I click on data and it opens up the data tools, over here on the right, it says data analysis tools. Now, if it doesn't say data analysis, if you don't see that icon, that just means it's turned off. So if you buy or download Excel, the program, or Microsoft Office, by default, it comes turned off. So if you've never turned it on, you'll have to turn it on once, and then it'll be there every time you use Excel. So if I click on the data analysis Toolpak, I want regression down here. So you'll see a lot of options. Some of them might seem familiar or have familiar terms. Others, if you haven't covered those topics yet, don't worry about it. We just need regression. And if we're going to use the regression function, we just have to tell Excel, what is our data? So it's asking you up here at the top, input y range and input x range. So it's basically saying, what are the y values? What are the x values? So if I click on this cell, actually let me get rid of this because it's getting in the way. So if I click on this cell, I'll just drag the mouse over the y values. And then I'll click on this cell, drag the mouse over the x values, click and drag. And that's it. Now Excel knows what data to use, and just click OK. Now when you click OK, it's going to give you the information on a separate tab. So if you click OK, you'll see it pops over to another sheet. And so let me just copy this over to the sheet that we're working on. And let's pop it in right here. Okay, so there's a lot of information here that we don't need. You'll see the, you'll see the, where it says multiple R, that's our correlation coefficient. That's the 0.695126 that we have also down here. And you'll see here the coefficients. This is all we need for the regression line. These are the coefficients the same slope and the same y-intercept, just rounded to more decimal places than we need. Again, following the directions, we would round that to negative 22.6 and 0.446. So, okay, so two ways of finding the regression equation: using the scatter plot or using the data analysis Toolpak. You obviously don't have to do both. So now let's get the best predicted value. So I'm going to put that down here in this blue cell where I've typed in best prediction from regression equation. And so, like I said, that basically just means take this x value and plug it in to the x in our equation. So I'm just going to use Excel like I would be using a calculator. So in this cell, I'll just type in equal B0, which is the y-intercept, so that's right there, plus B1, which is the slope, times the x value. Now you could type in the numbers negative 22.6, 0.446, and 78.6. I like just clicking on the values. Either way, doesn't matter. You should get 12.4556. So based off of the data from those 23 countries and based off of the regression equation, our estimate is that if a country has 78.6 internet users per 100, then that country should have about 12.5 Nobel Prize winners. So now over here on the top right, the last part of the question, you see, how does it compare to the country's actual Nobel laureate rate of 2 per 10 million? So our prediction is 12.5, and our actual value is 2. So we have four choices. Is it A, B, C, or D? A, the best predicted value is very close to the actual value. So the actual value is 2. So is it somewhere between maybe 1.5 and 2.5? That would be maybe close to the correct answer of 2. B, the best predicted value is not at all close to the actual rate. C, so I'll say not close. C, the best predicted value is the opposite of the actual rate. Well, if the actual rate is 2, the opposite would be negative 2. And D, our predicted value is equal to the actual rate. So let's say in C it would be equal to negative 2, which is the opposite, or in D it says it's equal to the actual rate. So our prediction, which is down here, our prediction, is it close, is it not close, is it opposite, or is it equal to the actual number of 2? Well, it's 12.5. It's not equal to 2, it's not equal to negative 2, it's not close to 2. So I would say B, our predicted value, is not close to the actual value. And that happens sometimes, and that's also probably because of this. Probably because of this. The correlation coefficient is not very close to 1. So if the correlation was 0.99 or 0.98, that's very close to 1. That means our prediction based on our equation should be very accurate. But in this case, we have only a moderate correlation. So it makes sense that our predicted value might be off, might actually be way off. So these predictor equations, these regression equations, they really only have like a statistical value when we have a really strong correlation, when our correlation is somewhere around 0.999897, something very, very close to 1. Okay, that about does it for this problem. I hope it was helpful.